I asked you to write down the definition of the multiples. So a multiple is the product of a number and any whole number. 0, 1, 2, 3, 4, and so forth. Okay, so the product, what does product mean? The answer to a multiplication problem. So product means you're multiplying, right? So here we want to, on number 1, it says write the multiples of 4 and 12. All right, so it says 4 and 12, and I apologize because I forgot to do 12. So we'll just write the multiples below, okay? So multiples of 4. We've got 4 times 1 is 4. 4 times 2 is 8. 4 times 3, 12. 4 times 4, 16, and 20, and 24, and 28, and 32, and 36. Very good. All right, so now I'm just going to do 12 right down here, okay? So let me draw a line. So we can do, and we're going to do the same multiples, okay? So we've got 12 times 1, 12, 12 times 2, 24, and then 36, and then 48, and then 60, good, and then 72, very good, and then 84, and 96, and 108, very good. So now we want to circle all the multiples that they have in common. So let's see, we've got 12, right? 12 and a 12. We've got a 24 and a 24. Anything else? We've got a 36 and 36. Okay, so those are all the common multiples that we have listed. What is the smallest of all of those common multiples? That should say common multiples. Yes, 12. Very good. So 12, that means that the 12 is the least common multiple. So here we want to find the least common multiple. It says here you can find the least common multiple by using a number line, making a list, or by using prime factors. Very good. Now I'm just going to really go really fast through the first two methods because that's not the way I want to show you. I want you to show your work. How do you think I'm going to ask you to show your work? Using the cake method or the factor trees. I'm going to ask you to use the prime factors. Is everybody clear? All right, so go ahead and write down the heading and the rule there. All right, so on a number line, we're going to find the least common multiple of 2 and 3. So here we have a number line, 1 through 12. And it says we're going to put a red X above each non-zero multiple of 2 and a blue one over the multiples of 3. So for 2's, we're going to put a red X over top of 2, 4, 6, 8, 10, and 12. Over the 3, we're going to put a blue X over 3, 6, 9, and 12. Right? Now, if you look to see on the number line where they have two X's, a red X and a blue X, those are the common multiples, right? And then to find the least common multiple, you just pick the lower number. So the least common multiple of 2 and 3 is 6. And that's how you look at it on the number line. Using an organized list. This is just like what we did with the factors and we listed them. But here we're using multiples. So the multiples of 2, again, 2, 4, 6, 8, 10, 12, and so forth. The multiples go on to infinity, right? Factors is a set list, right? Multiples go on forever. That's what that ... means, okay? And then for 3, there's the list, 3, 6, 9, 12, 15, and so forth. And then, once again, you can look at the ones that they have in common and then choose the one that's the smallest. So again, you can see that 6 is the least common multiple. All right, so using a factor tree with to find the least common multiple, we are going to get our prime factorization. We will get the prime factorization of each of the given numbers. So 14 can be broken down to 7 times 2, and 21 can be broken down to 7 times 3. Now, the difference between the least common multiple and GCF is we only took the common one and multiplied them together for the GCF, right? For the LCM, you're going to take the common one and you're going to multiply everything else, all the other factors. Is that clear? So here, to get the least common multiple, we're going to multiply 7. Remember, you write the repeats only once, right? You multiply 7 times 2 times 3, so that's going to give me 42 is my least common multiple. Does everybody see how you wouldn't want to, the least common multiples could get big, right? So you wouldn't want to list all of the multiples. Does that make sense? Okay, so finding them using the factor trees or the prime factorizations is a good idea. Okay, so let's do an example. So for 2 and 6, let's do 2 and 6 using the factor trees first. Okay, so we'll do the factor trees. Okay, we already know that 2 is prime, right? So if we are multiplying, if we're doing a factor tree, and we do a complete factor tree, that's going to be, even though 1 is not prime, we're going to put 1 times 2. Is everybody clear? 1 times 2. And then for 6, we're going to break that down to 2 times 3. Very good. 2 times 3. Now, we can see that we have a 2 in common. And how many times am I going to multiply that? Just once, right? So 2 times, no, you only write it once, right? And then we've got a 3 over here, right? So we're going to multiply times 3. Now, I'm not going to write times 1 because number 1 is not a prime number, right? Remember that was kind of like a little asterisk that I told you, a footnote that I told you at the beginning. So you're not even going to multiply by 1. And if you multiply by 1, does it change anything? No, it doesn't change anything. So we don't even have to multiply times 1. Does that make sense? All right. So in order to find our GCF, we just multiply 2 times 3. I mean, not GCF, LCM, right? LCM. And that's going to be equal to 6. All right, so for letter F, we're going to do the cake method, okay? So we're going to write 4, 5, and 10. 4, 5, and 10, and then we're going to do our little upside down division. Now, we want to know what number, what is the smallest number? Now, what is the smallest prime number that I can divide into most of those, or some of those? 2. We'll do 2, right? So we're going to put a 2 out here. So now when we do this, we're going to do 4 divided by 2 is 2. And then 5 divided by 2, that doesn't go evenly, so we're just going to knock that out. We're going to put an X there. Okay? And then 10 divided by 2 is 5. Very good. And now, everything's prime, right? Okay? So, now remember, that doesn't say 2 times 5. That's just X out. Okay? So, now, or maybe we should put a star. You want to do like that? Just so you don't think it's multiplied, okay? All right. So now, to find your least common multiple, you're going to multiply that number. That's if we just wanted the GCF, then that would be the GCF. But now we're going to multiply that number and the numbers on the bottom. Is everybody with me? So here, this is going to be, to get the LCM, we're going to multiply 2 times 2 times 5. So 2 times 2 is 4, times 5 is 20. And that is your least common multiple for 4, 5, and 10. What do you notice about letter G? Yes. They're all prime numbers. If they're all prime numbers, am I going to be able to do this factor tree and this cake method? If they are all prime, what do you think I'm going to multiply? All those numbers, right? Right? So here, to find the LCM for letter G, you're going to multiply 3 times 5 times 7. Okay? So 3 times 5, let's do 5 times 7 is 35. And then 35 times 3 is 'Very good. Is everybody clear with that? So if they're all prime, all you have to do is multiply those numbers. All right. So we just figured this out. If I circle the numbers, the prime factors, in our cake method, if we circle them, that tells us what numbers we're going to multiply. Okay, so we're going to circle the 2, and the 5, and then look at the shape that the circle makes. The circle makes an L. L for least common multiple. Very good. All right, that's a good thing to remember. All right, Ernesto has a painting class every 2 weeks. Kamala has a pottery class every 5 weeks. Ernesto and Kamala met at the art building for class this week. How many weeks until they see each other again? So we want to know, when is it going to be the same time that they're going to meet again later in the future, right? So if you look at that question, how many weeks will it be until they see each other again? Okay, when is it going to be the same number again later in the list? Does that make sense? So that is how you know you're going to find the least common multiple. You got it? So here, where they're doing the list, they have 2, the multiples of 2, and the multiples of 5. And then the common multiple, 10 and 10, that's the least of the common multiples. That's the least common multiple is 10. So Ernesto and Kamala will see each other again in 10 weeks.